Hi, and welcome to episode 3 of this series on IFR holding procedures. In part 1, we learned how to calculate the dimensions of a holding pattern in zero wind. In this episode, we will learn how those dimensions change when there is a wind. Wind changes the inbound leg, cross-track, and diagonal distance in predictable ways. In order to analyze these changes, we will first deal with crosswinds, with no headwind or tailwind. Then we will deal with headwinds and tailwinds with no crosswind, and once we understand them separately, we will put them all together. Well, let's get started. The diagram shows the dimensions of a zero wind hold, as we determined them in part 1 of this series. Now imagine we have an 18-knot crosswind from the hold side like this. To maintain the inbound track, we will need 8 or 9 degrees of drift correction, as shown here. But how will the wind affect the turn to the outbound leg? During the 1-minute turn, the crosswind drifts us the same amount it did on the inbound leg. But how much is that? The amount of drift is exactly 0.1 nautical miles for every 6 knots of crosswind. So in this case, the diameter of the turn will be 0.3 miles less than in zero wind. At the other end of the hold, we will have the same amount of drift, but in this case it will increase the diameter of the turn, like so. The diameter of the turn will increase from 1.4 to 1.7. Thus, we must target a cross-track of 1.7 miles at the outbound end of our hold. I would like to emphasize at this point that this formula is universal. It works whether you're flying a Piper Cub or a 777. Cross-track must be adjusted 0.1 miles for every 6 knots of crosswind. You can see that the outbound leg of the hold is no longer parallel to the inbound leg, so we need to give some thought to what heading we will fly on the outbound leg. To approximate the drift adjustment required on the outbound leg, estimate the amount of time it takes to fly the hold minus the inbound leg. In zero wind, that would be 3 minutes. In this case, that's roughly 3 minutes. Then divide that time by the time it takes to fly the outbound leg. In this case, the outbound leg will be a smidge longer than 1 minute, as you should be able to see by just looking at it. So, 3 divided by just a smidge more than 1 is just a bit less than 3. And that's exactly how much more you need to apply drift on the outbound leg compared to the inbound. So in other words, if it takes 8 degrees of drift on the inbound leg, expect it to be just under 24 degrees on the outbound leg. One final question to be answered is, what is the revised diagonal distance? We need to know this in order to know when to turn back inbound. In zero wind, we know it was 2.6 nautical miles, but you can see that when cross-track is increased, the diagonal distance increases as well. The rule of thumb that I use is to increase the diagonal distance half the amount I increase the cross-track. In this case, I'm going to increase cross-track by 0.3, so I will increase the diagonal by 0.15, which makes it 2.75. But that's too precise, so just round it off and call it 2.8. Before we give this a try, let me emphasize that the numbers you come up with when you estimate cross-track and diagonal distance for a hold are supposed to be a starting point. When you actually fly the hold, you can reduce or increase them as needed to perfect your hold pattern. Okay, ready to give it a try? Okay, here we are, inbound to the Vancouver VOR on the 270 degree radial. Cleared to hold west on the 270 degree radial. The wind is from 180 degrees at 18 knots. So this situation exactly conforms to what we have just discussed. I have slowed to 120 knots indicated. Remember, the true airspeed is 131 as always. Ground speed check, 131 knots. As I pass the 2.2 nautical mile mark, I will start the timer so you can see that it produces a 1 minute lag. I am flying a heading of 098 degrees to stay on track, in other words 8 degrees of drift. I expect nearly 24 degrees of drift on the outbound leg, so the required outbound heading will be 246. As we cross the fix, I will turn right to 246 degrees. Waiting for the flag to flip. There it goes. Time. Turn. Right heading 246. Track, the HSI and number 2 are already set to 090. Throttle, fine tune for 120 knots. And talk, report entering the hold. As we roll out on the outbound leg, I notice that the cross track is roughly 0.3 less than usual. I start the timer when the flag flips, but I'm not really going to use it. As I fly along, I monitor the cross-track and diagonal distance. I will turn inbound when the diagonal distance is 2.8, and I need a cross-track of 1.7. There's 2.8, and I roll into the turn. Cross-track was roughly 1.7, so it should work out well. Okay, watch the distance as I roll out. The distance is 2.2 nautical miles as I start the timer, so we know this hold will work out perfectly. Since we already know the inbound leg will be 1 minute, let's reset now for a crosswind the other way. This time we have the same wind, and we will hold on the 270 degree radial again, but non-standard, left turns. In this case, the crosswind will increase the diameter of the first turn by 0.3 and reduce the diameter of the second turn by 0.3. Notice that with 18 knots of crosswind, the same 0.3 adjustment is required in the cross track. But this time we are targeting a reduced cross track at the end of the outbound leg. 1.1 nautical miles. As far as drift correction goes, it is exactly the same as last time, just under 3 times the inbound drift, so the same heading of 246 should work fine. Lastly, we must consider the diagonal. The zero wind diagonal is 2.6, remember, but since we have reduced the cross track, we must reduce the diagonal. I use the same rule of thumb I gave you a few minutes ago. I reduce the diagonal by half the amount I reduced the cross track. In this case, I'm reducing the cross track by 0.3, so I should reduce the diagonal by 0.15. That would make it 2.45. As always, I round that off and call it 2.5. Okay, let's give it a try. Once again, we are inbound to the Vancouver VOR on the 270 degree radial. We notice the same drift as last time, 8 or 9 degrees. We already know it will take 1 minute from 2.2 nautical miles to the station, but I will start the timer for you to see it once more. Ground speed check, 131. I am waiting for the flag to flip. There it goes. Time. Turn. Left this time to 246. Track. The HSI and number 2 are already set to 090. Throttle, confirm speed at 120. And talk, report entering the hold. As we roll out on the outbound leg, I glance at the cross track and see that it is roughly 0.3 more than in zero wind. Now we simply fly until the diagonal distance is 2.5 and the cross track should be 1.1. There's 2.5 and we turn inbound. As we roll out, watch the stopwatch. I start the stopwatch as we roll out, and you can see the distance was 2.2, so this will work out perfectly. We are at the time limit for this episode, so in part 3b we will look at the effect of headwind and tailwind. See you next time.